लाइव के लिए
एक बार लाइव हो जाए
हो गया है लाइव.
Good evening, everyone. Welcome to our resource person today, Professor Masood Siddiqui, my colleague, and the participants who are watching this interactive session live on YouTube. This is one of the interactive sessions, as as discussed in the discussion forums. This is one of the interactive sessions with our resource person, Professor Masood Siddiqui. He will be taking up your doubts and discussing a topic simultaneously. It is before I invite Professor Siddiqui, I would like to give a very brief introduction about him. Professor Siddiqui is engaged in the area of decision sciences and pan-area chair of decision sciences and chair faculty development in Jaipuria Institute of Management, Lucknow. He has a PhD in mathematical statistics and was CSIR fellow in mathematical sciences. His area of expertise is business analytics, multivariate data analysis, decision modeling, soft operations research, research methodology, etc. Professor Siddiqui has a wide experience of consultancy, and he has also taken more than 200 FDPs or MDPs in different areas. He has also co-authored the famous book, Statistics for Management. He has over 40 research papers to his credit in various international acclaimed journals and has more than 140 Google Scholar citations, including 10 H-index and 10 I-10 index as of right now. So we welcome you, Professor Siddiqui, for this session. We are really grateful for you to give us your time this evening and interacting with the participants. Before I invite you, I would like to request the participants that they can pose their doubts in the YouTube chat box, and we will take their doubts from there on with the professor. Thank you so much. May I?
Okay, thank you, Dr. Shipra, and thank you, Dr. Ashish. And welcome to the session, all the participants. So we are primarily revising the three concepts that we have done. We started with them in the first session. We have covered related to the quality of the data or exploratory data analysis. Then we have covered significance testing that constitute parametric tests as well as non-parametric tests. Then we move to regression analysis. So we will revise these concepts, right? Actually, these concepts are the first three topics that are normally taken up whenever you are considering to write some research paper or thesis or anything. And as I have mentioned, as soon as you receive some data, so that was actually the first acquaintance with the data. So the first task we perform is related to screening of the data. Right? Just like in the earlier videos, the screening of the data means we screen the data for two objectives. Number one, we examine whether the data is of good quality or not. Means that if data is of acceptable quality, then only we move forward for our analysis. If data is not of good quality, then there is no point of moving with that data. So the first point we examine in the screening of the data is the data quality of the data. So let me share the whiteboard and I will revise these concepts. Then I will run one or two analysis just for the example. Then I will take doubt related to screening of the data and exploratory data analysis. Okay. Right. And if any one of you are having problem, then that problem can be taken care of. Right. So I am sharing my screen. Okay. This whiteboard will be shared with you. So, but actually everything is there in the notes, so you don't bother about anything. So the first thing is we have collected the data. Right? Actually, the previous steps are related to research design that we are not covering in this relation in this session. That are considering to be dependent upon the research design. Now, as soon as you have collected the data, right? So after collection of the data, we go for data screening, right? What do we mean by data screening? Actually, it consists of exploratory data analysis, right? This is the first instance of the data analysis, right? And it is mainly for environmental reading also. So there are two objectives related to data screening. One objective is to examine or explore quality of the data, means whether the data is of good quality or acceptable quality or not. And the second aspect is related to want to summarize the data. Why summarization is important? Because it will give a basic idea or the exploratory idea about the data. And this exploratory idea will be confirmed in the future tools. With respect to data quality, normally we go for the first aspect is whether our data is having large number of missing observations or not. This is the first instance that we examine whether our data is having large number of missing observations or not. Normally, we go with the two criteria. If number of observations, missing observations are below 10%, we will go with the data. And the second is if there is a random pattern related to missing observation. Random pattern means there is no defined pattern. Suppose you are collecting data from various sources. For a particular demographic segment, there is no data. So there must be some reason, right? A well-defined reason that has to be explored. So if these two characteristics of the data, we go forward. Right? But if these are not the characteristics, means our missing data is more than 10% or there is some well-defined reason. So if our missing data is more than 10%, normally we go for Normally we go for data imputation, missing value imputation or missing value treatment. We go for missing value imputation or missing value treatment. Right? But obviously there is a limit. Suppose we have more than 50% of missing observation. Right? Then obviously there is no point of going with the missing value imputation or missing value treatment. Why there is no point of using missing value imputation or missing value treatment? Because in these methods, normally we use some measure of central tendency. We use some measure of central tendency. Right? Means we may use mean, we can use median, or we can use some linear trend in order to impute the missing values, linear trend. But if large number of missing observations are there, more than 50%, and even if we impute, so apparently there will be no missing observation after the imputation. But in this case, there won't be any variability. There won't be any variability because everything has been replaced by same number. Since there is no variability, so there will be loss of information. So because of this aspect, there is no point of imputing so many observations. So we will explore the things further. If missing observations are with respect to variables, we will simply delete the variable, right? Because that variable is not giving us any information. But if missing observations are related to cases, then there is no point of moving forward. You have to recollect the data, right? Otherwise, there will be a big problem. So this is the first aspect. Next is, if our data is not following a random pattern, then we have to identify the reason and try to remove that reason. So this is related to missing observations, right? Then the second call, then we move to the second aspect. Let me have one more slide. The second aspect related to data quality is, related to examining presence of outliers or extreme values. As you must have seen in the notes, they are two different things. So we start by taking both outliers and extreme as the same thing, but as we move forward, then we differentiate between outliers and extreme values. And the third aspect related to data quality that we examine is related to whether our data is following normality or not, right? So we will cover these two aspects. Means we are examining whether our data are containing outliers or extreme values. What do we mean by outliers or extreme values? Means they stand apart from the data, right? Means normally they destroy the inherent property of the data. Suppose we are considering a batsman for inclusion in our IPL team, and we want to pay him according to his average performance. Suppose we have taken up his score for the last 10 innings. His score is 200. So 1, 2, 3, 4, 5, 6, 7, 7. Right. So if we calculate the average or the mean of this batsman, the mean is approximately 23. Around 23 it would be. Around 23, right? Okay. So it gives the impression that this batsman is having an average batting average of 23. So if we take up this value, right, then obviously it will give a false impression about his batting ability, right? Why it gives the false impression related to his batting ability? As you observe the data, normally the tendency of the batsman is to score less than 10 marks, 10 scores or single digit scores, right? But because of a particular score that is 200, which apparently does not belongs to the data set, right? The average increases to a large value. So it gives a false impression. So this 200, which stands apart from all the other observations, is known as extreme values or outlier. So normally they destroy the property of the data. So they should be taken care of. So how they can be taken care of? The first instance is we compare mean and median. The concept is, since mean depends upon all the observation, so it is badly affected by outliers or extreme values, right? And since median consider only the middle value, so it is not much affected by outliers or extreme values, right? So we compare mean and median. Right? Next comparison is related to we compare mean and 5% trend mean. 5% trend means 5% lower and upper values has been deleted. So this is a second comparison. Then we look for histogram. They are the visualization tools. We look for histogram, frequency curve, or stem and leaf, right? Or box plot, right? Here the best tool is related to box plot, right? So if values are different, so as you know, the concept of the box plot actually consists of 4 parts, right? This is the first whisker, this is the first box, second whiskers, right? So everything covers 25% of the observation. So this is 25, right? This also covers 25% of the observation. This also covers 25% of the observation. This also covers 25% of the observation broadly, right? Means if we identify the values, so this is first quartile, this is a second quartile or median, this is the third quartile, right? So all the values which are up to one quartile range. One quartile range means quartile range, as it has been mentioned, they are Q3 minus Q1. So everything that lies in the range, one quartile range. would be included here. In the same manner, everything that is included in one quartile range would be included here also. But anything that goes beyond this point, if they lies in between 1 to 1.5 interquartile range, then they are termed as outliers, right? And beyond that, they are termed as extreme values. In the same manner that this occurs on the lower side also. So SPSS takes care of outliers and extreme values. Outliers are normally denoted by circles and extreme values are denoted by star. Normal recommendation is outlier can be included in analysis, but extreme values should be avoided. Right? So this is the concept related to outliers and extreme values. Now I am explaining the third concept that is related to normality of the data. Right? Why normality is so important? Because a number of tools require normality of the thing under consideration as a desired property. Like if we compare, we have two types of tests that we will cover in later on, parametric test, and we also have non-parametric test. Normally, parametric tests are more efficient. They have better discriminatory power. They are more efficient. They are having better discriminatory power. But the thing is, so apparently parametric tests are supposed to be better as compared to non-parametric tests. But the thing is, they require normality they require normality for all the variables. Then only parametric test can be employed. But if normality is not there, then we have to go to the less efficient non-parametric test. So though they are less efficient, but they can be used for more general situation, because here normality is not at all required. More general situation. So obviously, if in our data, suppose a variable is following normal distribution, other variable is not following normal distribution, so you should go for non-parametric test, right? But if the first variable is not following normal distribution, then there must be some reason. So you can perform any transformation. I will tell you how the transformation can be performed, right? So they require normality. In the same manner, when I discuss the regression analysis, right? So for the linear regression, we use the estimation technique as ordinary least square estimation, right? And there is a characteristics, or there is an assumption that all residuals or error terms or epsilon should follow normal distribution, right? So if this characteristic is not there, then you cannot use ordinary least square estimation. So here normality estimation is important. Further, if we consider the classification techniques that I haven't covered, if we consider the classification techniques, then two techniques are very important. One is discriminant analysis. Classification technique means our y, or the dependent variable, is non-metric or categorical in nature. Our dependent variable is non-metric or categorical in nature. Categorical means they have different categories like 0, 1, 1, 2, and so on. Right? Yes, no. like, dislike, satisfied, not satisfied, purchase, not purchase, will remain in the organization, will leave the organization. That person will buy a particular share, that person won't buy a particular share, right? So when we discuss the classification technique, then two tools are very important. One is discriminant analysis. Let me write it again. One is discriminant analysis. Other tool is logistic regression. Right? Finance in finance and economics, it is a very common tool, very applied tool. It is also known as logit, right? So how can we differentiate whether we should go for discriminant analysis or logistic regression? Normally, discriminant analysis is a more powerful technique, having better discriminatory power. This is better. But the thing is here, all the predictors or independent variable must follow normal distribution. So here again, normality is required. Here there is no assumption. Means our variables are not following normal distribution, then we go for logistic regression. So normally in finance and economics where we have value series, so normally they don't follow the normal distribution. That's why logistic regression is more popular when we consider the cases of finance or economics or the research papers of finance and economics. But if we go with the survey research, right? Survey research primarily in marketing, HR, or any type of survey research, then normally go with the discriminant analysis, right? There is one more thing where normality is so much required. You must have covered structural equation modeling. In structural equation modeling, we have two concepts. One is confirmatory factor analysis. Other is structural model or theoretical model. Here also, normality is a desired property. Normality is desired. Right? So these are the reasons because of which examination of normality is so important. So now I will explain how the normality can be examined. Definitely, I am taking the SPSS also, but we should cover first the concept, then we move to the analysis. So how normality can be examined? The first is there should not be large deviation between mean and median values. Then the normality would be there. Second is coefficient of skewness should be approximately 0. Coefficient of kurtosis should be approximately 3. Right? Next is if we consider histogram of frequency curve, then we should have a bell-shaped curve. In the same manner, if we consider stem and leaves, then we should have a horizontal bell-shaped curve, right? Next, we have other visualization tool like box plot. So if we draw a box plot, so these two whiskers should be equals to each other, and these two boxes should be equals to each other, approximately equals to each other. Now, and the last one is normal probability plots. Normal PP plots. Right? So for normal probability plots is drawn with the observed values on the x-axis and expected value. Expected means assuming something. So expected normal values. Yeah, expected normal frequencies on the y-axis. So obviously, if distribution is perfectly normal, then observed value and expected value both would be same because normality is there. So if our most of the points are concentrated around the line, then normality can be taken care, normality can be assumed, right? So this is normal PP plot. But all these visualization tools are much dependent upon your observation. So there is a particular test for normality also. Right? We normally recommend two tests. One is Kolmogorov-Smirnov test, right? And the other is Shapiro-Wilks test. They all are in the notes, right? Shapiro-Wilks test is more powerful, right? But badly affected if we have large sample. Right? So, right here, what you do here, the null hypothesis is H naught is we take that population distribution follows normal distribution, and we look for p-value, right, which is denoted by significance. If p-value is small, normally take 5%. So if p-value is less than 0.05, then we reject H. Right? So by this method, normality can be examined. So as you have seen, there are n number of tools, but there is no perfect tool that give you a direct answer. So that's why the discretion of the researcher or discretion of the analyst is so important. So we should have knowledge about every tool, then only we can have a judicious decision. And it rarely happens in the real life or the real data that everything gives you the same message. So that's why we have discussed so many tools. So the important thing is running SPSS or running any software is not so difficult. Even if we go for Python or all the codes are there. So running the software or running any language is not so difficult. The main thing is how they can be interpreted and how and which proper tools should be taken care of. So now I am sharing data just to show how these things can be done, right? Though it has already been covered in my session, but I am just repeating it. So this is a data that we are considering the Ventura data, right? This is the Ventura data, right? Now, as you must be remembering, there is an observation in the Q2, Q1 cell, right? Uh, which is situated on case number 55, where we wrongly have a value 610. So because of that value, uh, everything is badly affected, right? Suppose this value has been corrected, means this value has been corrected as 61, right? So how we move forward, right? So one method is, if we cannot correct this value, then it is better to delete this case. So by deleting, we will have a sample loss, means instead of 60 observation, we would be having only 59 observation. But all the other problems would be taken care of. So let me tell you what are the other tools that can be used, right? So here the main button is the analyze, where we perform most of the analysis. But there are some interesting options are there which are available in other buttons also. Like if we go to transform, then there is an option of replace missing values, right? Suppose our first quarter, suppose just for an example, is having missing observation. So we enter this variable, right? So here a new variable would be created, right? The name of this variable is Q1 sale, right? Q1 sale underscore 1, right? Why this a new variable has been created? Because all the missing observations of this variable would be replaced by series mean. So you can use series means you can use series of nearby mean, sorry, mean of nearby points, median of nearby points, right? linear transformation, linear trend, and so on. So if you press OK, then all the missing observation would be replaced, right? So by this method, you can impute the missing observation, or you can impute the data. So this is one of the option. There is one more option. Some of you have asked about the transformation of the variable, right? Suppose we want to transform a variable, right? Suppose Q1 is behaving badly and we want to transform Q1. So Q1 can be transformed as, we create a new variable. This is Q1, right? Let me show you the suppose we want to transform this variable. This is Q1 sale, and this variable is is behaving in an erratic manner, or this variable is not following normal distribution, suppose, right? And we have examined that there is no outlier, there is no extreme value, but even after that, it is showing high variation. So we want to transform this variable. We want to transform Q1 variable. So we go to transform, right? Here you find an option that is known as compute variable. So from transform, we go to compute variable, right? And we take the target variable as, right? We take a new variable, target variable as Q1 sale. Suppose we are performing ln transformation. So this is Q1 sale ln, right? Means we have used ln transformation, right? So how this transformation can be done? Means we want to take ln means log of base e, right? We can also have lg, that is log of 10 for this transformation. So here we are having functional group. We know that log, lg or ln both comes under arithmetic functional group. Otherwise, you can use all also. So here we have two options. One is lg, which is at the base 10. Other is ln, which is at the base e. So if you click this option, then this tool is being explained. Return the base e logarithmic of the numerical expression, right? So we select ln, right? We double click, or we can use this option, right? Let me repeat again. Oh, okay, right? Suppose we want to take lg, so we can have log, right? And now I am deleting this, right? So there are two methods of transferring this function. You can select ln, and you can press this button also. Otherwise, you can double click ln. So this is ln. Now it is demanding which variable is to be transformed. Suppose we have selected the Q1 sale. So a new variable Q1 underscore sale underscore ln will be created, which is the natural logarithmic of Q1 sale. So if we press OK, so I'm showing you, right? So here, as you see, a new variable, that is a transform variable, has been created. So this is one of the method by which a new variable can be created. In the same manner, anything can be standardized also, means by subtracting mean, and by subtracting and dividing by standard deviation. So this is a new variable. Anyway, so for analyze, since I am explaining the exploratory data analysis, so we go to analyze, then we go to descriptive statistics, and the best option is explore. So we will go with the explore. Suppose we have selected Q1 sale. Now that value has been modified. So now you will see that everything has been changed drastically. So I have selected the first variable as Q1 sale. Right? Then we go to statistics. We can check certain parameters like descriptive statistics, M estimators, outliers, and so on. Then we can have plots also, box plot, stem and leaf, histogram, normality plots, and so on. Right? Okay, so we have created this, and this is the missing value consideration. If we press OK, let me show you the output. So here we are having the output. There is no missing observation. Now you see that there is not much difference between mean mean is 72, and 5% trimmed mean is 71.98. Means it is approximately 72. So just one observation has made such a large difference. So that's why 610 was an extreme value. Even median is much closer to this value. And if you follow M estimator, then all M estimators are approximately 72. Right? In the same manner, if you have examination of the extreme values, not now the highest value is 90, second highest is 88, next is 88, and so on. So there is not much of the difference, right? Even if we go for the normality, here p value is 0.05, which is not below 0.05. So we can say that distribution of Q1 cell becomes normal, right? And this is the shape of the histogram, right? This is stem and leaf, and if you observe normal QQ plot, so here most of the points are lying very close to the straight line. So normality assumptions can be made. Right? This is the shape of box and plot. So this we have discussed. Now I am moving back to my one moment. Right. Now, so suppose here when we run this analysis, then entire set of the data is being examined. Means whole of the Q1 cell is being examined. Suppose you want to compare Q1 cell with respect to two types. Means you want to compare Q1 cells of the urban area and Q1 cells of the rural area. So one method is you can impose some type of filter. The other method is you can go to analyze, then we go to descriptive statistics, then we go to explore. Right? So now we want to bifurcate sales of the outlets in the first quarter with respect to two types. Means we want to bifurcate the whole of the output with respect to urban outlets and rural outlets. So this type of outlet is being taken in the factor list. Right? In the same manner, suppose you want to compare sales of the first quarter with respect to 4 locations, then you can enter location in the factor list. So here I am showing you the bifurcation of this output with respect to urban outlets and rural outlets. And if we press OK, right, then again, now you see the whole of the output is being divided into two parts. One with respect to urban outlet, we are having 37 urban outlets and 23 rural outlets, right? 67.86 is the average sale of the urban outlet and 78 is the average sale of the rural outlet. Everything is being divided into two parts, right? So in this manner, you can divide the data. Let me tell you one more thing. Suppose you want to normalize the data, means you want to standardize the data. So by standardization, we mean, let me share the whiteboard. Right? By standardization, we mean, suppose X is our data and we want to standardize the data. What is the objective of standardization? If it is not following normal distribution or it is showing high variation, so we can standardize. So standardization means it would be converted to Z distribution, means we subtract mean from all the values and divide it by standard deviation, means X minus mean of X divided by standard deviation of X. So when we standardize the data, then 99.73% of the observation would be in between -3 and +3. Means approximately 100% of the observations would lie in this range. So this is the benefit of standardization. So now how standardization can be used? Right? We go to this data set, then we go to analyze, right? Then we go to descriptive statistics and then to descriptive. Here, suppose we want to standardize Q1 cell. So we enter Q1 cell in the variable box. And here we check save standardized values as variable. And if we press OK, then you can see a new variable has been created, which is the standardization of Q1 cell. So here, if you observe, then most of the values, 99.73% of the values would be in the range -3 to +3, right? So this is standardization. So this is all about exploratory data analysis. Now I can take questions. Yes, now you can post question. We should take questions related to this part.
Okay, so as of now, we have initially three questions. So one of the participants, Milind Patel, he asked initially only that to test t-test, to have this t-test, is it necessary to take check for equality of variance?
Yes, because not equal, right. I will take up the t-test, but the first assumption for the any parametric test, right? Whether this is z-test, t-test, or ANOVA, the first assumption is it should follow normal distribution, right? Because they are the parametric test. Second is, if we want to compare two population with respect to t-test, then there are two options in the t-test. One, we are having equal variance, other is we are having unequal variance. So equality of variance is not at all required in t-test, right? If variances are equal, then we go for equal variance option. If variances are not equal, then we go for unequal variance, right? It is same for ANOVA. The only assumptions which are required for t-test or ANOVA is they should follow normal distribution. Okay. Next question.
Yes, second one is from Mr. Kumar Gaurav. Kumar Gaurav's question is about Likert scale. So he says that some researchers consider it as ordinal scale, yes, while others consider it as interval scale. So how to cater to this issue and what are
okay. So actually it depends upon the domain to which a researcher belongs, right? Normally in economics or the pure sciences, right? Normally Likert scale is being considered as ordinal scale. But if we go for any type of survey research, right, means even with economics and finances, lots of behavioral finance and behavioral economics papers are there. So in order to measure behavior, you have to use some Likert scale. So they consider it as a metric scale, right? Means they consider it as an interval scale, right? So normally some of the researchers belonging to the economic area don't consider, right? So whenever we have real observation on the ratio scale, then that only is being treated as the metric scale. But in most of the researches, that has been taken care of. So all the good journals, even A-star journals belonging to marketing, HR, or behavioral finance, or this type of things where some survey research is being considered, they do consider a Likert scale as interval scale, means metric scale. Okay.
So related to this only, Vishal Trivedi is asking which Likert scale is good, 7, 1 or 5?
Right. Here again, in any analysis, the thing is nothing is absolute, right? Means everything is having one positive aspect and one negative aspect also. That's why we go for the trade-off. So if we have a lower number of categories like 5-point Likert scale, then it becomes easier for the respondent to reply, right? So if we consider the convenience of the respondent, which is the most important part of a researcher or most important ethics of a researcher, then we should go for the 5-point Likert scale. But as we increase the category, it moves more towards the normality and more aspects has been examined. So whenever we consider some new product development or anything which is related to subconscious mind, means whenever we have to apply SEM or any higher order tools, then normally we go for 7-point Likert scale, 9-point Likert scale, or 11-point Likert scale. So again, with 5-point Likert scale, convenience is for the respondent, and for 9 and 11 or 7, analysis becomes better with respect to efficiency, but that becomes more troublesome for the respondent. So there may happen some halo effect. Halo effect means a respondent got irritated and he or she begins to answer by taking a particular value, right? So these are the issues.
Okay, so as you were explaining, using the values, Dr. Morlin KSJ, they asked that if we replace the missing value, then does the result change, or they would be, in the new
Obviously,
data?
that is just a compromise, because we replace values by uh, some middle value. So variability is affected. Fine. So if missing values are not much, then we should use missing observation. But how missing value treatment is so important. Suppose we are considering regression or any associative relationship too. Means we are considering regression, cluster analysis, factor analysis, SEM, right? Or logistic regression or discriminant analysis. Then if one observation is missing in a variable x1 and some other and only one observation is missing in some other variable x2 for some other case, but when we run the model, then both the cases would be deleted. So the effective sample size decreases by a large amount. So that affect the missing value treatment. That affect the efficiency of the analysis. That's why missing value treatment is required. But if we have large number of missing observation, then obviously the variability is badly affected. And this variability actually gives us the information related to variables. So again, there is no definite answer. You have to make a judicious decision related to the percentage or volume of missing observations. Right? So that's the reason that we should go with the good researchers, or we should read the good research books or good analytical books. So all these books don't give any gospel recommendation. And there is no Brahma Vakya. Okay, right. Next
Yes.
question.
So yes, one participant, Kangan Jain, they asked that will it be correct to apply testing on one transformed variable and the other variable as per original value?
Right, but if you want to compare those variables, right? Suppose you want to employ t-test, right? You want to employ ANOVA, right? Then obviously both should be transformed. But in regression, suppose only y is being transformed, then it doesn't matter. You can interpret that y, right? But otherwise, whenever these variables are taken up and they are to be compared, then obviously the same transformation should be applied everywhere.
Okay. Okay, so we do have two more questions now, and they are fundamentals related to the software. So Lakshmi Priya asked a very important but a very basic question: that is it free to download the SPSS software? One,
No,
and
you can get a 30 in a last in the last pandemic they are giving a student license of 90 days, but now probably they are giving 30 to 45 days.
okay,
Right.
yes.
So that's why the use of Python, R, or this type of software has uh, uh, been much in the use, because they are free software, right? Open end software. But SPSS is not open.
Okay. And similarly, Vishal Trivedi is asking how we can find any data file for the practice in SPSS software. Any resource if you can, suggest. And one more
The
question related.
one resource is, whenever you go, let me show you this also.
Okay.
Uh, this is the SPSS, right? You will go to data, and here you have an option of uh, means there are a number of data files are also available, right? So if you go to data, then uh, let me check where this option is. Open database, or there's an option where we can have data files also. Right? So in the C drive, they are available. But here also there is an option that by this, let me open SPSS again. Right. One moment. Let me save the output. This is output of 29.5. Otherwise, uh, all the good books like Marketing Research by Naresh Malhotra or Multivariate Data Analysis, right? Multivariate Data Analysis by here, they are all having data sets. So on internet, we have a large number of data sets are available, right? So let me show you, right? Here, right? If you run the tutorial, right, then you can have a number of data sets that are available, right? So by this method, you can go with the having a new data sets. Okay, right.
Okay,
Next
so
question.
yes, related to this resource question only, if there is any specific book you can recommend for multiple regression, types of multiple regression.
The question arises, what is the level of the researcher, right?
Hmm.
If you go with the basic, even you can use my book, that is Statistics for Management by Levin, Rubin, Siddiqui, and Rastogi. This is a Pearson book. It gives all the basic. But if you move slightly on the higher level, then there is a book, Marketing Research by Naresh Malhotra and Satyabhushan Das. Again, a Pearson publication. That is a good book. And if you further go for the higher analysis, means some more thing, then there is a very good book, Multivariate Data Analysis. It is a Cengage book. It is by Multivariate Data Analysis by Hare, Tatham, and so on, right? So I will share that name. So that is also a very good book, right? But if you belongs to economics stream or finance stream, then you can go with Basic Econometrics by Gujarati, right? So these are the certain books. I will share the books, name of the books.
Okay, sir. So these were the questions as of now, sir. So thank you so much for answering them, and participants are really thankful for you taking these questions.
Right. So now I am
Yes.
moving to the second part that is related to hypothesis testing.
Okay, sir.
Okay. We have to wait for 1 minute. Right. So the next concept is hypothesis testing. And I prefer the name significance testing because it gives a clear message. So in significance testing, in approximately all the researches, we examine for the totality. We examine the things for population or totality. But we have evidence or data from sample only. Right? So there is always a big question whether there exists a significant difference, means substantial difference between sample results, right, and population results. Right? Now the issue is, since more than more than one samples are possible, and we always go with the one sample only, right? So here all the sample values, which are better known as sample statistic, are random variables, means they can never be known with certainty. Since they are random variable, so in order to express them, we have to develop the probability distribution. So that's why, so this whole concept of hypothesis testing or testing of significance is based upon probability distribution, that is known as sampling distribution. Means what is the distribution of sample statistic is based upon sampling distribution. So for significance testing, we use the technique of hypothesis testing. We use this technique. So we start with proposing the hypothesis, right? So normally the null hypothesis is proposed, right? And this hypothesis is tested. So all the comments should be on the null hypothesis only. This hypothesis is being proposed and it is tested. H1, as per the binary notification, it is just the opposite of null hypothesis. So always null hypothesis is very important. Means all the tests are prepared by considering null hypothesis of a particular format. That's why we always discuss what should be the null hypothesis, right? So here we have different type of tests. Number one, I have made it clear that we have parametric tests as well as non-parametric tests. So for parametric tests, normality is required of all the variables, and for non-parametric tests, normality is not at all required. So among parametric tests, though when we teach to students or even to statistic students, we start with the Z test. But in social sciences or all type of survey research, Z test is not at all possible, because for Z test, population standard deviation should be known, right? But never ever population distribution is known. So we never employ Z test in the real life. That's why in SPSS, Z test is not at all there. So we start with the T test, right? So T test means population SD sigma is not known. Sigma is unknown. So we would estimate sigma by sample standard deviation. So that is the T test, right? And what is the requirement for the T test? Just same as parametric test, that population should follow normal distribution. Otherwise, we have to go with non-parametric test. So we have different type of T test. The first one is one sample T test. Right? Means suppose we want to examine for a particular value of mean. Suppose we want to examine whether our mean is 100 or not, whether our average sale is 100 or not, whether our average performance of the student is 100 or not, right? So we examine for a particular value. So for that, only one sample is required. So for this purpose, we go with the one sample T test, and every other thing remaining the same. If p-value or significance is small, less than 0.05, then we can say that we reject H0 at 5% level of significance. Otherwise, we cannot reject. So this is the one sample test. After that, we have two sample test. This is used to compare two population parameters or two population means, right? Here the hypothesis is H0 is mu1 equals to mu2 or mu1 minus mu2 equals to theta. Theta is a particular value, right? Normally we have this, means we simply have this comparison. So here we have two options. One is two samples are independent, and the second is two samples are dependent, or we are having paired t-test. So for independent, we have to check whether our sample follows independent samples or not. So the condition for independence means that two samples are collected separately, means there is no connection, means one belongs to male, one belongs to female, means all the units that belongs to the first sample won't belongs to the second sample. So there is no actual connection between these two samples, right? On the other side, if we take information uh, where two samples are though involved, but they are related. Suppose I am taking high school performance and the inter performance of the student. So obviously, suppose you are comparing my performance. So my 10th performance will be compared with my 12th performance, right? Suppose I have joined a weight loss program. So my previous weight would be compared with my post weight, right? So these observations are paired or dependent. In the same manner, suppose you want to examine the impact of generation with respect to shopping habits, right? So it would be better that you select a family, and in the family, you take information from generation X, means the parents, and the generation Y or Z, right? Means the second generation. Because by this method, other factors has been taken care of. So here we use pair t-test. So first, we would select whether we should go for the independent sample or we should go for the pair t-test. Both are having same hypothesis. But now in independent sample test, we have two options. Number one, whether we consider equal variance or we should consider unequal variance. So if equal variance is there, then the first part would be interpreted. If variances are not equal, then we go for the second part. Means it doesn't matter whether variance are equal or not. In both the cases, independent two sample test may be employed. But for the interpretation purpose, you have to select one output only. So if variances are equal, then we go for equal variance. If variances are not equal, then we go for unequal variance. So in order to examine the equality or the homogeneity of variance, the recommended test is Leavenet test, which is there in the SPSS output only. And for the pair t-test, there is no such issue. So it is the example of two sample t-tests. Now, we go for more than two samples. Means we are considering k independent sample test. Means we are comparing parameters or mean of more than two populations. Right? So here we go with, since they are bifurcated with respect to one aspect only, so that is known as one-way ANOVA. So here one-way ANOVA is employed with the same concept. If significance is small, then we reject H0. So when we reject H0, then obviously we go for H1. Since up to two sample, either things would be equal or they are not equal or greater or less. But when we have more than two samples or more than two parameters are involved, when we are comparing more than two population, then the reverse of H0 may not necessarily be inequality of all. It may be possible that some are equal and some are not equal. So here in ANOVA, we propose H1 as at least two groups are different. Means at least one mu I is different from other. Then also this H0 won't hold. So if we reject H0, then obviously the question arises, which particular mu I or what are those mu I's which are different from others. So for that purpose, we go for post hoc analysis, okay, which is better known as multi multiple comparison analysis, where we compare all the observation. So again, in post hoc analysis, we have two type of outputs. We have equal variance output, where normally we go with Tukey or Duncan's test. And there is the other option, that is when equal variance cannot be assumed. Then we go with unequal variance. That is known as Tamhane. Right? So we will select only one. Whether for equal variance, if variances are equal, then we go for these tests. And if variances are not equal, then we go with these tests. Right? So the first thing is we examine equality of variance. Then only one of these two can be interpreted. So we examine equality of variances. So for that purpose, we use the Leibniz statistics. Okay. So this is all about a parametric test, right? In the same manner, we are also having non-parametric test also. So let me explain non-parametric test also. Then I will run some analysis just for the interpretation purpose. So we have non-parametric test also. Means where normality cannot be assumed. Right? We have number of tests, right? For one sample, we have run test, right? For two samples, right? Suppose we want to, if our information is categorical in nature, means we want to compare proportion, then we go for binomial test. Right? If our information is metric in nature and we want to compare mean, right? Then obviously the question arises whether we are having independent sample or we are having dependent sample. We have option for two independent sample tests. So normally for two independent tests, the most preferred test is Mann-Whitney test that I have covered also. And if samples are not independent, means they are related. So for related test, for two related samples or two dependent samples, we go for sign test, or there is a better test that is known as Wilcoxon test. Right? So they are all available in that box. So they are used for the two samples. Right? In the same manner, if we have more than two samples, means k samples, then we can also go for different number of tests. Number one, if our data is categorical in nature, means we want to compare proportion of more than two population. Compare proportions with the hypothesis as P1 equals, P1 equals to P2 equals to P3 and so on. Then we go with the chi-square test. Then we go with non-parametric chi-square test. Right? But if our data is metric in nature, so we go for k independent sample test parallel to ANOVA. Right? And here the test is Ruskell-Wallace test. Right? Here two in the Mann-Whitney is parallel to independent sample t-test. Wilcoxon test or sign test is parallel to pair t-test, and Ruskell-Wallace test is parallel to ANOVA. So, right? So these are the direct tests. We have one more option there, which is related to whether two attributes are independent or not. So two attributes are related or two attributes are independent or not. Means whether the gender and the likeliness are related or not. Whether the gender and smoking and not smoking are related or not. Whether the gender and a person would invest in the share or not, they are related or not. So for that purpose, we perform cross-tabs analysis. Right? I have taken the example of this also. We use cross-tabs analysis. Cross-tabs analysis is actually chi-square test of a chi-square test for independence. Right? So these are all these tests. So let me show you these tests, then I will take the questions again. So let me open the first file. And this is a data file. Right? So all the parametric tests are available. All the parametric tests are available under compare me. One sample t-test, independent sample t-test, paired t-test, and one way ANOVA. Suppose we want to use one sample t-test, right? And we want to examine whether the average sale of the second quarter is 70,000 or more than 70,000. So here we enter the first variable as sale of the outlet in the second quarter and test value as 70, right? In option, we have confidence interval. Then we press OK. So let me share the output. Here we are having the output, right? And this output can be interpreted from the p-value. Okay, means this p-value is greater than 0.05 for two tail test. For one tail test, it should be divided by 2. So it becomes less than 0.05. So if we consider this value for one tail test, then obviously we would reject test not, and we can say that sales are higher, significantly higher as compared to 70,000, right? But if we are considering two tail test, means whether the sales are 70,000 or not, then we cannot reject this hypothesis, right? So this is the p-value, right? Now the next question, suppose we want to compare sales of the second quarter with respect to urban outlets and rural outlets. So we have to use two independent sample tests because the urban outlets are independent with respect to the rural outlets. The catchment area, normally the catchment area of urban outlets would be different from that of rural outlets. So I have selected the second variable, and then we go for the type of outlet. This type of outlets are entered into the grouping variable. We define the groups as 1 and 2, and then we continue, and then we press OK. So this is our output, right? Here, this is a two independent test, right? So as you see, we have values for equal variance. It is just by chance that these two values are same, but it is not always the rule. So if equal variance are assumed, then we would interpret the first value. If variances are not equal, then we will go for the second value, right? So for that purpose, we have to use Leibniz test of equality of variance. So here the p-value for Leibniz test of equality of variance is 0.596, 59% or 60%, which is greater than 0.05, means variances are equal. So we would interpret the top value, right? Obviously here these two values are same, so it doesn't matter in this case, but it is not the rule. In some situation, they may be different. So if they are different, then obviously we go for the first value because variances are equal. And if variances are not equal, then we have to go for the second value. Okay, so this is the independent sample test. The second question is, suppose we want to compare sales of the second quarter with respect to the sales of the third quarter. So obviously, if we are considering a particular outlet, so for that particular outlet, sales of the third quarter should be compared with the sales of that outlet only for the third quarter also. So in that situation, we have to use dependent sample test or the paired t-test. So we can use pair t-test by going compare me Then we go for paired sample test. And suppose we have entered the second quarter and the third quarter, right? And we will run the analysis. So this is the output. Okay. So here, this is the output. Here, as you see, the p-value is less than 0.05. So we reject the equality, means sales are different. So if you see, the sales of the outlet in the second quarter is significantly higher as compared to the third quarter. Means there is substantial decrease when we move from the second quarter to the third quarter. Right? So this is the paired sample test. Now, next for ANOVA. Suppose we want to run analysis of, we want to compare the Q4 sale with respect to 4 locations, northern, eastern, western, southern. Since the number of samples or number of groups are more than 2, so we have to use ANOVA or one-way ANOVA. We go to analyze, then we go to compare mean, then one-way ANOVA. Here the variable under consideration, or the test variable or the dependent variable, is sales of the outlet in the 4th quarter. And we create factors from location because we have more than 2, right? And we have one option from equal variance, one option from unequal variance. Because we don't know if H0 is being rejected, then which output is to be interpreted, whether for equal variance or for unequal variance. So on the forehand, we are having both the options. Then we go for both the options in post hoc analysis. Then we go for the option. We check descriptive just to have a mean and standard deviation for all the values. And we also have homogeneity of variance, which is the Leibniz test. So they are used just for the purpose of comparing, right? So first we go for ANOVA. If this p-value is less than 0.05, means H0 is rejected, then we interpret multiple comparison either with Tukey or Tamane. So in order to decide whether we should use Tukey or we should use Tamane, we take helps of Leibniz test. Like in this case, though it is not required because here p-value is not less than 0.05, it is greater than 0.05, means there is no significant difference in the sales of the 4 location in the 4th quarter. But if this p-value is less than 0.05 or H0 is rejected, then we take help of the homogeneity of variance. Here p-value is greater than 0.05, means variances are equal. So we make interpretation of Tukey. So this is all about post parametric test, right? And suppose this data is not following normal distribution, then we have to use, this is just for an example, though we have used separate data for the non-parametric test. You must be remembering the name of that data is mutual fund case. So for non-parametric test, we go for non-parametric, then we go for legacy test. Here we have all the tests. Here 2 independent sample tests. Let me show you. This 2 independent sample test dialog box for Mann-Whitney is very similar to that for the t-test, right? So you can use this test also. In this manner, the non-parametric test can be used, right? So this is all about the second part, that is testing of hypothesis. So any question related to this?
Yes, sir. Yes, sir. There are 2 questions. One from Rekha Menon. Sir, can in social science research we treat Likert scale as an ordinal scale and the data as a non-metric?
No, normally in social sciences research, apart from economics, right, there are a number of supporting documents also that Likert scale or this type of scale are treated as interval scale that belongs to the metric scale. Otherwise, you can never use SEM or this type of tools or even factor analysis, right? Because in social sciences, we collect information on number of variables. So there are high chances that these variables are correlated. So that's why we go for exploratory factor analysis, or for confirming, we go for confirmatory factor analysis. And normally these tools are better when we use metric analysis. So that's the answer.
Yeah. The second question from Milling Patil side. Why t-test is a small sample t-test call, even though it is used for large samples?
This is a misnomer, right? Normally, it is mainly because of the teachers who teach statistics. Normally, the difference people tell that if sample is large, you go for the z-test, and if sample is small, you go for t-test. But this is not correct. Actually, whenever population standard deviation is known, whether the sample is large or sample is small, we go for the z-test, right? And whenever population standard deviation is unknown, sigma is unknown, we have to use sample standard deviation in order to estimate sigma. We have to use t-test, right? But actually what happens when we don't use the software, either Excel or SPSS? So normally we go with the tabulated value from the books. So normally books provide values up to the sample size 30 only for T. So if we have a number of observation more than 30, then obviously the proper values of T table is not available. So in that case, it is approximated by Z distribution, by central limit theorem, right? So this is the case. But whenever we use some software, either with Excel or SPSS or anything, then if sigma is not known, whether the sample is small or sample is large, we have to use Z-test. Sorry, we have to use T-test.
Okay, sir. Thank you, sir. There are only 2 questions. You can continue.
Any other question?
No question, sir. No other question.
Okay. So let me show you cross tab also. Right? I'm using the other data file. This is mutual fund. This is the data file, right? So here, I am showing you one interesting thing also. In my lecture, I haven't created this variable. Means how willing categories is being created, right? Actually, our data consists of, right? Actually, our data consists of these 4 variables only. One is willingness to purchase the mutual fund. Next, related to size of the company. Next, related to familiarity. And next, related to position of the executives, right? So if you consider the data, here only the first variable is on the scale 1 to 11. So this is the scale category. Otherwise, all 3 variables like size of the company, small company, medium company, and major company are categorical or nominal in nature. Similarly, familiarity is also not on the metric scale. It is again on the categorical scale, having 3 categories: 1, no experience; 2, medium experience means less than 3 years; and 3 means high level experience is more than 3 years. So again, these are the categories. Suppose we want to explore the relationship between familiarity and willingness. So here familiarity is a categorical variable, but willingness is a metric variable. So in order to use a chi-square test of independent or cross-tab, normally it is recommended that if both the variables are metric, non-metric or categorical in nature, then analysis would be somewhat better. So we have to convert the metric variable, that is willingness, into categorical form, right? That is non-metric in nature, right? We do this from the very start, right? As you obtain more than 60%, more than 40% marks, your score is pass, means your category is pass. If you score less than 40% marks, your category is fail, right? So we convert the metric data into categorical data. In the same manner, even in grading system, if your score is beyond a particular value, means it is in between 9 to 10 grade points, then you are assigned A star. If you have grade score in between 8 to 9, your grade category is A, right? So we can always convert metric variable into non-metric variable. So I am taking an example, right? So, suppose we want to convert, we have a 1 to 11 values, right? means this is a 11-point scale, right? It is related to willingness. This is metric variable. It is metric variable extended Likert scale. Now we want to categorize it, means we want to convert in a non-metric scale, though it has less information, or we want to convert in a categorical scale, right? And we want to develop 3 categories, right? So one category can be from 1 to 4. 1 to 4 means low willingness, right? We can have a new category as 1. Then we have 5 to 7, right? Since we have 11 points, so 2 categories may have 4 points and 1 category can have only 3 points. So we are putting 3 in the medium in this part. This is known as medium willingness. This is category 2. And the third one is from 8 to 11. This is high willingness. This is category 3. You can use some other categorization also. I am taking just an example. Right? You can means here I have categorized 1 to 4 as low willingness, 5 to 7 as medium willingness, and 8 to 11 as high willingness, right? So you can always convert a metric data into a non-metric data by this categorization. You can convert the categories as per your preference or as per some recommendation as suggested by some literature review. Anyway, so now I am sharing this option, right? So here we have willing, and we want to create a new variable that would be metric in nature, that is the willingness category. So for that purpose, we have to go to transform. In transform, we have 2 options. One is record into same variable. If we use this option, record into the same variable, then the original variable would be replaced. Means we would means the actual data would be lost. That will be a big problem. So always recommended that don't touch the previous data. Instead, create a new variable, right? So we are recording into different variable, and the original or the input variable is willing, which is a numerical variable, and we convert the output variable as suppose it has been named as willing category, willing cat, right? We can use label also. Means we would convert willingness, which is a numerical variable, into a new variable that would be categorical in nature when we define with the name willing category, willing cat. So here we have to define old and new values. We would press old and new value. So this is the dialog box. Now you can here we have old values and here we are having new values. So you can convert one by one, and the other method is you can use range also. So here the first range is you would convert 1, 2, 3, 4, 1 to 4, right, into a new value that is 1, right? Means you would convert 1 to 4 values from the willing to a new category 1 that belongs to the new variable that is being created, that is a willing category. So we would convert 1 to 4 to 1, right? So here old values are in the range 1 to 4 and new value is 1. In the same manner, we can convert 5 to 7, right, in the value 2. So we would convert 5 to 7 into the new category 2. In the same manner, we have 8 to 11 in the old, and the new value is 3, right? We can add. So 8 to 11 is being converted into 3, right? So this is the option you can check. Now we continue and we press OK. So one moment. Now, as you see, we have we have one more category that we have one more variable, that is willingness category, right? Now we can define this category. We go to the variable view, right? And this willing category is nominal. SPSS has identified that since you have created 3 category, so this is non-metric in nature and it is nominal, right? Suppose you don't want to place decimals, you can make decimals as 0. You can use label and you can define these values also. Since you have defined one as low willingness, right? One has low willingness for this variable willing category. 2 has medium willingness. Sorry. In the same manner, 3 as high willingness. Okay, so if we define, we have defined these values, right? These values has been defined. So now on the data view, we have these values. As you check, we have the willing category also, right? Now you want to explore relationship between familiarity and willing category. Now both the variables are categorical in nature. So it can be done by going to analyze, then we go to descriptive statistic. Here with an option of cross tab. So here we take a variable familiarity in the row and willingness category in the column, right? So these variables has been entered. You can use clustered bar chart also for the visualization purpose. In statistic, since it is based upon chi-square statistics that I have explained in my slide. So you can have chi-square test just to examine whether there exists a relationship between 2 attributes or not. And we also want to examine the strength of the relationship. So we have lambda, we press continue, and if you want the observations also, so you can have counts, observed and expected. If you want the percentage, then you can check these options also. And then when you press, you will have the output, right? So I am showing, now I am sharing the output again. This output has been discussed, right? So I am not taking up, right? Here the chi-square statistics is quite high. So p-value is less than 0.05. So we reject H0 of independence, means attributes comes out to be significant. Then we go for the lambda. Here the lambda values are small. So we can say that we have significant relationship, but this relationship is weak, right? This is all about cross-tab analysis. So Dr. Ashish, should I take questions or should I explain regression also?
So you can continue.
Okay.
Yeah, but there are 2 questions you can answer.
Yes.
Yeah.
Kindly mention the question.
Yes, sir. Yes, sir. Rajendranath that wants to ask, if some sample size is large, can we assume the distribution is normal?
Right, as I have given in my notes also in PPT, that normality can be taken care of by taking a large sample. So obviously the sample size is large, so that can be assumed at asymptotic normal. So this is the point of using a large sample size. That can be assumed as normal.
Okay. So one more question from Vishal Trivedi. Which one multivariate analysis is good? Multiple regression technique or structure equation modeling?
I will explain all these techniques, right?
Okay.
Though I am covering only regression, but just for the for the research purpose, all these relationships are very important, right? So I will take care of everything, right? When they are. Okay.
Sir, you can continue, sir, please.
Okay, right. And one more thing, since I have given you notes which are very comprehensive, even much beyond the level that I covered in the workshop, right? But they are very comprehensive. They are covering every aspect. So you can, and they are from a number of good books and all the concepts that I gathered during my past years. So you can use those concepts to decide everything. So you will get answers of many things from those slides also. So let me share the whiteboard to explain all the multivariate techniques as a whole. Actually, we have two types of techniques. I am now explaining all the multivariate techniques. This is very important in order to decide which type of tools you are going to use or how you should make your questionnaire. Because if you have knowledge of these techniques, then you can prepare your questionnaire or the instrument accordingly. So normally in multivariate techniques, we go for associative techniques. We go for associative techniques. Means we want to associate variables, because if more than one variables are there, then there should be a purpose of taking more than one variable. They won't be independent if you are going for some research paper or for some thesis. So normally we go for associative techniques. These associative, they are only the associative technique. They are not a causal technique. For causal, you have to go for experimental research. This is very important, right? Means even regression or anything cannot, even structural equation modeling cannot univocally gives you the cause and effect relationship. So for cause and effect relationship, either you should go for experimental research or you should go for some higher order tools like Yanger's causality test and so on. So we divide associative techniques into two parts. One is dependence technique. In the language of analytics, they are known as supervised learning algorithm. So one is dependence technique, other are interdependence technique, which are unsupervised learning. So in dependence technique, we have label data, and in interdependence, we don't have label data. By labeling, we means we have dependent variable or explained variable and independent variable or explanatory variable. Here, all variables are same. There is no demarcation between independent and dependent variable. In dependence technique, we have number of techniques like regression analysis. Right? Then we have discriminant analysis. I will make them correct clear. Or logistic regression. Or logic. We have one more technique here. That technique is probit analysis. In regression, also we have a number of techniques like normal regression, stepwise regression. We have dummy variable regression also. Right? In discriminant analysis, then we have, these are the dependence technique. Then we have canonical correlation also. Right? So these, and here, when we move forward, we also have structural model also. That is a part of SEM. Right? And they are also known as theoretical models also. They are part of SEM. I will discuss where we use SEM. So here we have a lot of dependence technique where there is demarcation between independent variable and dependent variable. But where we don't label data, they are known as interdependence technique. Then normally we have factor analysis or better known as exploratory factor analysis. I will make them clear. What do we mean by factor analysis? And there is one more technique that is known as cluster analysis or k-mean clustering. Right? And if we go for the same part, right, then there is a tool that is known as conformatory factor analysis. So say belongs to the interdependence part. So I am showing you a slide. So that slide there would be shared with you, right? I have not included that in our lecture, but I'm using, just wait for 1 minute. Just 1 moment.
Yes, sir.
Just 1 moment, right?
Yes,
I am
yes.
taking. Okay. So now I am sharing a slide that have description about these tools also. Right? It will save the time. Right. So this is the study of the associative relationship. Here everything is being mentioned. So here the first column is related to independent variable, other is the dependent variable and the technique. If independent variable is single non-metric, dependent variable is single non-metric, we go for cross-type that we have discussed. If independent variable is single, means in our case, the independent variable was location, right, which is non-metric, and dependent variable is sale, which is single and metric. For relationship, we can also go for ANOVA. If we have single independent variable and single dependent variable and both are metric in nature, we go for bivariate regression. And multivariate regression is simply extension of the bivariate regression, where dependent variable must be single, right, and metric in nature, means either on the interval scale or on the ratio scale, and independent variables are multiple in nature. Then we go for multivariate regression. And now we go for this analysis. If independent variable is multiple and normally metric in nature, and dependent variable is single and non-metric or categorical in nature, then we go for discriminant analysis, for logistic regression, and for probit analysis. In logistic regression, we have bifurcation of yes or no, but in probit analysis, we simply count, right? Suppose an experiment is done related to advertisement on the 50 people, and out of 50, 30 says that they like the advertisement. So we don't go for the individual observation, whether a person is liking the advertisement or not. We simply count the proportion or the percentage of the people who are liking the advertisement. In the same manner, if you go for some drug testing, then in drug testing, we normally don't go for whether the drug is effective or not. We simply count how many patients or how many virus are being killed. Means how many patients got healthy and how many virus are being killed. So for that purpose, we go for the probit analysis. Now, this is the case when independent variable um, is multiple, but there is a combination of metric and non-metric variable, means some of the variables are non-metric in nature. Then we go for the dummy variable regression. If our dependent variable is metric and single, and if our dummy variable, if our dependent variable is single and metric, then we go for dummy variable regression. If our dependent variable is single and non-metric and we have this situation, then we go for dummy variable discriminant analysis or dummy variable logistic regression. And this is the case when along with the independent variable, the dependent variable is metric also. Then we go for the canonical correlation or structural equation modeling. So this is a demarcation of associative technique. In the same manner, for interdependence technique, we have two analysis. One is EFA. I will make the difference clear. In EFA, we go for underlying dimensions. What do we mean by underlying dimensions? Underlying dimensions means we consider reduction of the variable. We consider reduction of the variable. Means we consider correlation among variables. Right? So if the variables are under consideration, then we go for exploratory factor analysis. In cluster analysis, we go for segmentation. In segmentation, segments means we try to create groups of respondents which are internally homogeneous and externally heterogeneous. So here we look for reduction of cases. Means reduction of respondent, reduction means we consider the association of the respondent or the cases or the cars or type of shares, type of employees. So we go for reduction of cases. So we consider association or difference among cases. Right? And what is the difference between exploratory factor analysis and confirmatory factor analysis? In exploratory factor analysis, we have variables. And from this variable, we try to explore the underlying dimensions or factors. Right? Means there is no theory behind. The theory is developed through the empirical way or through the data only. But in confirmatory factor analysis, we have a theory. And we want to confirm this theory. And this part belongs to the measurement model. Right? Belongs to the measurement model where we try whether the direction would be from construct, means who are underlying, to the variables. So variables are actually behave like indicator. We try to confirm whether this construct can be measured by these variables or not. So conceptually, exploratory factor analysis and confirmatory factor analysis are opposite to each other. Now the question whether we should go for regression analysis or we should go for the SEM. So in regression analysis, it has been mentioned that it is for the one layer only. One layer means we have independent variables and we have dependent variable. Only one layer only. But if we have multiple layers, like you have some service quality aspects. You want to examine the customer response with respect to service quality. And from service quality, you move to satisfaction. And from satisfaction, you move to repurchase intention. Then from repurchase intention, you move to loyalty. Right? So we have set of interdependence, dependence relationship, means we have multiple layer for the relationship. So here, SEM is proposed. But in short, SEM or CFA are used. SEM actually consists of two parts. One is measurement model, which is covered under CFA, and other is theoretical model. And this is an example of theoretical model because there is a theory behind. Okay. This is theoretical model, which is also known as structural model. Right? So SEM actually consists of these two parts. So for application of SEM, normally theory should be there. Right? So if theory should be there, then SEM should be preferred. But if we are going for the one layer relationship only, then regression can be used. Actually, SEM has been derived from regression only. Right? Since in statistics, we develop this model or we consider the theoretical aspects of this model. So obviously here also covariance. Covariance is an integral part of regression also. So this covariance analysis or this correlation analysis only goes to SEM. So actually SEMs comes from regression only, right? Again, there is a lot of discussion. Normally the pure sciences researchers or the researchers belonging to analytics or finance area, they don't consider SEM to be a good option. They either go with the regression or go with the simultaneous equation modeling, right? Normally SEM is preferred with the humanities or the social sciences. So this is the answer. Yes. I don't think that regression is required, because that is very simple, and I have taken a case and that has been explained in quite an extensive manner. So should I take up regression, or it is clear to all?
Sir, thank you. Hello. Hello.
Okay. Hello, Dr. Ashish.
Sir,
Hello.
am I audible?
Yes, you are audible.
Sure. You want to continue, or you should stop here? I suppose. I hope you covered all the things.
Right, because regression is very comprehensive. Slides are there, and even in SPSS, or everything is there. So we have around 8 minutes, so we can take questions also if some of participants are having.
Maybe I will let me check.
Okay.
Yeah. So no questions for on the topic. So participants are saying that your simplicity and attitude is very nice for delivering your lecture in in very informative manner and very interesting sessions. Yours that every participant is almost saying that's every very informative session. Thank you so much, sir. So you are explained the data in very simple manner. So on behalf of organizing committee and the Ramanujan College, we are very grateful to you, sir, for giving us time in this evening and interacting with our participants. Thank you so much, sir.
Okay, and I have shared an assignment also that is related to this data set also, right? Dr. Ashish?
Yes, sir. Yes, sir. I will share with the participants.
25 I share. Right?
I will share the participants.
Right. So they can have practice, and so that will be a learning also, means how the analysis can be interpreted. And if they have problem, they can always discuss. Okay, thank you. All the best.
Thank you so much, sir. Thank you for giving us time. We will definitely contact with you in the future. Thank you so much.
So I am
Namaskar.
leaving the Zoom session.
Yeah, sure.
Thank you.